Martin Rowe, I am here at APEC 2024. We are at the Power Integrations booth, and Andrew Smith is going to show us company's new device which can produce multiple output power supplies without having to use multiple DC to DCs starting from the initial power source. So Andrew, why don't you tell us about this device and how it works?
Very much, yes, very good. Your summary is very nice. What we've done is the single stage converter market for adapters, everybody uses it, it works very efficiently, we can get to more than 90%. If we look at multi-output power supplies, because they have to use separate output stages to control the regulation on the output, they might only achieve 80%. So what we've introduced with Innomux 2 is a way of getting to very high efficiency by using a single stage conversion process for multiple outputs that produces 1% regulation accuracy.
Okay, can you show us a little bit?
This is how it works, certainly.
Okay.
So we have a master control and driver IC called Innomux 2. On the secondary side is a controller. We have a barrier crossing technology that goes across the isolation barrier, and then we have a primary switch. And with this particular design, we actually have 3 different output voltage rails. And what happens is the Innomux is looking at what the voltage level is on each of these outputs. When one of the outputs voltage starts to fall, it requires a switching cycle. Innomux asks the primary side for a switching cycle, and we get a pulse of energy. Now this is where Innomux gets clever. It looks at the voltage level of each output, and for this pulse of energy that is just requested from the primary side, it uses a series of pass switches to decide which output gets that energy. So 75% of the energy would probably go to the output that requested the switching cycle, but a small amount of energy might go to one of the other outputs that requires a little bit of power to keep up, and the other output wouldn't receive any energy at all because it doesn't need it. And by adjusting the amount of energy delivered, we can get very good regulation without the efficiency drop you'd normally see from a multi-stage DC-DC converter.
What kind of switching speed or cycle do we normally see here?
So this uses a technique called variable frequency on-off control. So the switching frequency runs from about 35 kilohertz to about 100 kilohertz.
Okay.
Depending on the size of the load, the frequency of switching pulses will change. The advantage of that is it gives very good efficiency at light load.
Okay. And what kind of EMI issues do you run into? Or
EMI and audible noise is an interesting challenge with power conversion. So what we do with this device, first of all, it's using a soft switching process, which means the EMI on the primary switching stage is reduced, and we keep the switching frequency, even in peak conditions, below 150 kilohertz to avoid crossing into the EN55022 drop in allowable EMI. From audible noise perspective, we make sure that each switching cycle, each output receives a small amount of energy so that the switching frequency on each device is always running at the main switching frequency. So we avoid subharmonic issues associated with turning individual devices on and off at a different frequency. So we always stay above 30 kilohertz for normal operation, and we also have an engine within the device which, if it sees it moving into the audible range, shifts the switching pulses so that we don't go in this 25 to 5 kilohertz range, which causes audible noise. So one more thing about the Innomux technology is we can do constant voltage and constant outputs on the same power supply, still using the single stage converter. And that can be very good for one CV output and one CC for a display, or for a sophisticated TV. This is a reference design for that. What we do is we have a constant voltage output, and we have up to 4 LED strings. And we actually provide feedback to the Innomux. This is a little current measurement device that we add in series with the Innomux, and that allows us to do CC output on 4 different strings and CV output on the main string. And that means that we can simplify the power stage.
So constant voltage, constant current.
Exactly, yes. And if we want to do one constant voltage, one constant current, we use this approach, where we're actually looking at the current on the LED string, but also providing a constant voltage on a constant voltage string. So we're able to do CV and CC in the same design.